All right, let's talk about um, inverse trig, as well as just trig, I guess, in general with a circle. I know this one's kind of a spicy one from what we went over in class, so I really hope to clear up a lot of the questions that you may have, or just how do I get some of those numbers and stuff like that. So this might be a slightly longer video. I'm not really sure. We'll see. Okay, so I kind of went over this in class or the warm up. It's gonna kind of come up again, so I'm not like very worried about this. I'm gonna skip this still. Um, so when we talk about our Pythagorean theorem, right, we know that it is a squared plus b squared is equal to c squared. Now, ignore this 5. We're not going to be using that at all. However, with a circle from geometry, I hope that you do remember um, with a circle, there's a reason why we can use this formula as our circle formula. And part of that is because if you take a look at any point on the circle, right, any point on the circle on the corner plane, there's going to be some x. So it's some point x y, right? That's, I think we know that. Regardless if it's in the first quadrant, if it's in the second quadrant, if it's in the third quadrant, if it's in the fourth quadrant, it doesn't matter, right? If these are all some point x, y. So we can use this picture, this one right here, to kind of generalize the idea, right? So whatever I do here is going to be true in a second, third, or fourth quadrant. Now, at any point, what I can do is I can draw a vertical line from my point towards the x-axis. I can do that in the second quadrant. I can do it like this, like so, right? I can do that with the third quadrant. Do that with the fourth quadrant, right? For any of these, and then if I connect my point to the origin, right, I have a triangle, right? So again, I'm just going to generalize using the first quadrant only, but it's going to be true for any triangle that's made um, with any quadrant, right? So, but at any quadrant, I can draw a triangle like so, and I know the base is going to be of length x because this length is the same as this length, right? Which is, well, this is x units to the right. So that's x, and my height is y for a very similar reason, right? This is my y length, which is, of course, the same as right here. So my y and my x's are well defined, and because it's a right triangle, I can use my Pythagorean theorem a squared plus b squared equals c squared. And specifically, now that I have these new variables, I can use it as x squared plus y squared. But now our hypotenuse, we also know it's the radius of the circle. And so that's x squared plus y squared equals r squared. With this idea, and this is all from geometry, so I hope that this makes sense and it's kind of coming back to you. But with this information, I can quote unquote rename, restate, redefine my sine, cosine, tangent almost, as sine as being y over r, cosine as x over r, and tangent as y over x, using, right, even though I'm using opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, I can use the variables x, y, and r. And this is going to be very helpful in what we're doing today. So just as a quick example, and there's two of these, right? Just because they're in different quadrants, just kind of gives an idea of what the heck this is talking about, right? We can still use a formula. If you want to think about it as Pythagorean theorem, you can. You can think about it as your circle formula, you can, right? Because I don't know what my radius is, or I don't know my hypotenuse. X squared plus y squared equals r squared, and this is true for any point on the circle. In this specific case, we have the point 4, 3, so I'm going to go ahead and use those numbers. My x is going to be 4. 4 squared is 16. So I'm just skipping a couple steps here. 3 squared is 9. That's going to give me r squared. If I take the square root on both sides, I'm going to get square root of 25 is equal to r, which of course is 5. Now, just like before, right, this is a length, this is a radius. The radius will never be a negative value. Okay, so it's not, sorry, not just the length, but this is the fact that it is the radius one, because you're not going to have a negative radius just because you go this way or whatever, right? So the radius is always constant. It's always going to be always be a positive number. So here, what I have then is, again, I have my, and if this helps you out to just kind of label everything out, I mean, I would definitely do that. I would say, x is equal to 4, y is equal to 3, and my r is equal to 5. And so with that, I can label my sine theta, which is y over r. and that's 3 over 5. Cosine theta is x over r, which now is 4/5, and tangent theta is y over r. I'm sorry, y over x. Therefore, it is 3/4. Okay, so I'm just pulling the numbers that I have here, and I can find my trig functions. Okay, one more example where I have my point in a different section, right? So my theta is actually going to be very different. We're going to be looking at this specifically later. For now, I'm just kind of looking at like, okay, what is my sine, cosine, theta? So we're kind of taking this one step at a time. Okay. So once again, though, I can use my my x squared plus y squared equals to r squared. Why did I write that? X squared plus y squared is equal to r squared. X is -4. And now be careful. A lot of people mess this up, especially I've seen even some of the homeworks that some people have done so far. It's going to be -4 quantity squared, right? Because the value of x is -4, not just 4. Therefore, when I square this, I'm going to have positive 16. Here, I'm going to show this as well because people seem to not am not sure how to solve and get 48. I'll do that in 1 second. Here, I'm going to end up with the square root of 64 is equal to r, which is 8 is equal to r. So what this means is x is equal to -4. And apparently, I'm not very good at writing with my XP pen. Y is equal to 4 root 3, and r is equal to 8. So real quick, however, let me just show you how this becomes 48 real quick. This is the same thing as 4 squared root 3 squared, which ends up being 16 times the root 3 times root 3, of course, is just 3, and that's 48. Okay, so that's how I got 48. So again, sine theta is equal to y over r. That's equal to 4 root 3 over 8, which reduces to root 3 over 2. Cosine theta is equal to x over r, which is -4 over 8, which again reduces to -1/2. And tan theta is equal to y over x, which reduces as well. This is 4 root 3 over -4. My 4's will cancel, leaving me with just -root 3. Okay, so during class, everyone, every period, when I was seeing this was pretty straightforward. So I hope this makes a lot of sense. This is going to keep coming up for the remainder of this video, so I wouldn't be too worried about this. Sine, cosine theta, again, we said, right, sine theta, I really want to start using y over r, cosine x over r, tangent y over x. Okay, really want to start using these values instead, okay? So let's take a look at an example here. We had the point 2, 3, which is on the circle, x squared plus y squared equals to 13. What is the radius of the circle? You might be tempted to start calculating immediately because you say, oh, I have my x, I have my y, I can start calculating that. But remember, the equation of a circle is x squared plus y squared is equal to r squared. There's no need for me to actually well, I mean, I'm going to calculate it, but I'm not going to actually need to substitute this in because they must be equal. R squared must be equal to 13. I can just take the square root on both sides, and I don't need to do anything special here. I'm just going to leave it as square root of 13. Okay, so if I can't reduce this at all, just leave it. Okay, just leave it. Draw a circle to represent the situation. Now I'm going to cheat and just simply use a circle tool. Oh, I actually don't want that. Nice. Okay. Just because my circles in person might be okay. I don't think I can do that here. All right. So, and we want to also label the point 2, 3. So 2, 3, as you know, these are both in positive. So this is in the first quadrant somewhere. It doesn't really matter exactly where. Let's just say this is 2, 3. Now here are some terms that we haven't really talked about as much. Initial ray is going to be, I'm going to draw this in red. This is going to be this line right here, starting from my origin to just basically the positive x. This is my initial ray. Okay, it's just because we always start at that point. We always start when we talk about rotations. It's always going to start there. terminal ray, here, this just means the line that goes through the point. Again, so origin through the point like so. Okay, so these are what they are called. And specifically, with the last term here, we have been using this word a lot, but we talk about the angle of rotation. The angle of rotation in this case is going to be the angle between my initial and terminal terminal ray. Sorry, just trying to focus there. But that's the angle in between. I want the angle, or I should say, that is called the angle of rotation. Okay? So, using what I have, I can figure out all my values because I have my x, I have my y, I have my r. So, this part is the part that we just did. My sine of this angle, whatever it is going to be 3. That's my y over r, which is root 13. My cosine is 2 over square root of 13. My tangent is y over x, which is 3 halves. All right, now, this is the part that's going to be kind of tricky. What is the measurement of the angle of rotation? What is this theta? What is this theta? So what I can do is so I don't know if you remember from geometry, you should, that when you have a whatever, sine, cosine, tangent of an angle, so I'm going to just use sine as an example, but this is true for cosine and tangent. If you have sine of some angle, represented as theta here, that's going to give you a ratio, right? That's why we have opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, right? That's what the ratio is. If I have the inverse, now I'm going to take the ratio, and what I end up with is the angle, right? So, which we have learned in the beginning of this whole class, Algebra 2, the very first thing we learned was the inverse. The inverse means it'll undo something, right? So if you take the sine of an angle, gives you a ratio. If you inverse it, it'll switch those two things, right? It'll undo. Instead of giving you, if you take the inverse of a ratio, it undoes that to give you back an angle measurement. Now, in this particular case, again, because this is in quadrant 1, inverse sine, inverse cosine, inverse tangent will actually all give you the same value. So let's do, I'm just going to do, well, for me, for this one, I'll just do all of them so you can kind of see what I mean by that. So inverse of 3 over root 13. If you put this in your calculator, now be careful. If you use a TI-80, or I'm sorry, TI calculator or scientific calculator, most scientific calculators, it's going to have different modes, whether it be the degree mode or radians. Make sure to have it in degree mode. We haven't learned radians just yet, which we will coming up next topic, but I want to make sure I have in degree. So, and then for me, I have a TI-83. I want to click second sine, which is going to be the inverse. 3 divided by the square root of 13 gives me 56. I'm going to just round to nearest 10th, 56.3 degrees. Let's do inverse cosine as well. So be careful. It's not 3 over root 13. It's 2 over root 13. So I'm going to do the same thing, except now with inverse cosine and 2 over root 13. I get the same answer, which should not be surprising. Finally, inverse tangent. I expect the exact same thing since these are all working with the same, angle, 56.3, right? Because they're all talking about this angle measurement. So that makes sense. They all give you the same thing. Great. Awesome. The end. Okay? I am going to leave this one for you to try because this is also in the first quadrant. And there should be no issues there. All of your sine, cosine, tangent should all work out. If you want to try this out, go for it. If you don't, that's fine too. I really do want to go over these two, however, because these are a little bit different. Okay, so, but similarly, we have considered the point -2, 6. That's my x, that's my y. Again, they give me the equation of the circle, so I don't actually need to do anything in terms of solve, or not at least difficult solving. R squared is equal to 40, because x squared plus y squared equals to r squared. Again, take the square root of both sides. R must be, again, it doesn't simplify nicely. Now, for those of you that might know how to simplify this, you can get it down to 2 root 10. We're not going to do that. That's not really that big of an issue. Okay, I'm going to go ahead and steal this circle here, though. And in fact, I'm going to do that for the next one also, just so that it's all there. Um, and I'm going to go ahead and label where this is. Negative 2, 6 is somewhere in the second quadrant. Again, that doesn't really matter where I draw that, as long as it's a sketch. It's not going to matter too much. What is important is, again, if we have my initial ray, starts here, and my terminal ray, again, from my origin, goes through the point. Oh, that is not what I meant to do. From the origin all through the point here. And again, the theta that I have is going to be this right here, from where I start to where I end. This is the angle that I'm going to want. Now, for those of you that are thinking about maybe knowing, or if you know what like the inverse sine, inverse cosine, inverse tangent means, you might be thinking about, okay, how's this going to work? But we'll get there in just 1 second, okay? So again, I'm going to use the exact same, I'm sorry, do not label my point here. This is negative 2, 6. So my sine is 6 over root 40. My cosine is negative 2 over root 40. My tangent is 6 over negative 2, and I can simplify this down to negative 3. Okay, now I'm going to use all three again, and you're going to see here, this is the really tricky part. Okay, so I have inverse sine, which is 6 over root 40. So I'm going to go ahead and type that in. Inverse sine of 6 divided by the square root of 40. What I get is 71.6. Now, I would also say, go ahead and try to, see if you get the same numbers that I do. Okay, because that is going to be pretty important. Because if we're not getting the same numbers, then something's amiss. Okay? Inverse cosine. I get negative 2 divided by the square root of 40. And I have 108.4. Interesting. Finally, let's do inverse tangent of negative 3. Inverse tan of negative 3, gives me negative 71.6 degrees. Okay, so we got a problem here. Because clearly they don't give the same answers, and two of these don't make a whole lot of sense. All right. First of all, you have to know your calculator is a tool. It doesn't know the problem you're working with. It doesn't know what you're looking for. It does exactly what it's programmed to do. And for the inverse functions, they're programmed to do a very specific thing. We're not going to go into it, like what does it look like, what we're going to blah, 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 all that stuff. We're going to do that in pre-calculus. But what is important is you have to know that at this point, your calculator is trying to give you an answer that makes the most sense based on what it knows. Some things that you do notice, however, is that these numbers are the same, except one's positive, one negative. So I would say if you get any negative numbers, just for now I know in like those of you that are like really, they understand what these functions mean, you might be like, okay, that's not really true. But just change it all to positive for now, okay? And what is going on is for at least for the inverse sine and inverse tangent, what the calculator is finding is actually going to be, so if I'm going to drop a base here down this way, it's actually finding this angle. I'm going to call it something else just so we don't get confused here, but it's actually finding this angle alpha. So this is actually equal to alpha, and the positive version of inverse tan is also the same thing. That's not what I want. I want the orange. I want this rotation. That's what I want. I don't want this alpha. Okay? But so what I can do though is I know that if I go all the way around, right? If I go this amount, that's 180. So what I can do is if I go 180 and then I go back alpha, then I have the orange, right? So for both sine and tangent, again, in this case, I can do 180 minus 71.6 degrees is equal to 108.4 degrees. And it actually turns out cosine in this case gives us that answer directly, right? So again, I don't want you, and this is why I'm doing it all three to kind of show you, like, right now we're not at a point where we can fully understand or fully choose the correct inverse to use, right? But for now, like, it's okay to just choose any of them, but we do have to understand what the heck the calculator is trying to tell us, right? Again, this is where some of the things I kept on saying, like ways to kind of like check in with yourself, comes into play. I know this blue line is definitely greater than 90, but less than 180, right? So the fact that I see 71.6, that can't be right. That can't be right. That's less than 90 degrees. This is in the first quadrant. Same with this guy, right? So if you happen to use cosine and you got 108.4, wonderful. Awesome, you know? But for everybody else who use sine and tangent or inverse sine, inverse tangent, this doesn't make any sense. And you think a little bit, say, okay, what is the calculator trying to do? What is the calculator trying to do? In this case, it's finding the alpha of this triangle. Because again, remember that sine, cosine, tangent is usually looking for right triangles. Right? It's using the um, the ratios of our right triangles. All right. So be careful here. Be careful on this one. So we'll do one more example that I did not get to do in class. Or at least I don't think, not for all my classes. Some classes I did get to do, not all. But again, the radius, I know r squared is equal to 169. Now, in this case, I know many people did not know that the square root of 169 is actually 13. So this actually works out very nicely. -5, -12 is going to be somewhere over here. Again, I'll continue to draw out the initial as well as the terminal rays on this particular video, just because I have, I can just kind of talk through. Unlike in class where I kind of want to make sure and like talk to everybody and stuff like that. So I'm going to just go ahead and go through the whole thing. So -5, -12, that's my point there. And again, this is the rotation. Again, from start to end, this is the angle that I'm going to be looking for later. Notice that it's greater than 180 degrees. And in fact, this time, sine, inverse, cosine, inverse, tangent, none of them will give me a number that makes sense. Again, we have to figure out what is my calculator trying to give me. Okay, so we'll get there in just a second. Let's write down what my sine, cosine, and tangent would be. I have -12 over 13. Cosine, I have -5 over 13. And tangent, I have -12 over -5, which reduces, technically, to 12 over 5. It's positive. All right, so let's go ahead and do all of them again and see what makes sense for us to use and what doesn't. So I'm just going to write them all out first this time. So bear with me for just a second. And what I'm going to do is I'm going to put them in the calculator back to back to back. So inverse sine of -12 divided by 13. This is -67.4 degrees. Again, right, we just take the positive version for now. I know that, again, some of y'all might not be happy with that, but that's what I'm going to do for now. Okay, 112.6 inverse tan of 12 over 5. And this is the positive 67.4 degrees. Okay, so I would just ignore cosine. Honestly, I wouldn't use cosine for any of these, inverse cosine. I think it's just don't do it. Okay, because here, again, these two numbers, you can see they're the same thing. And the reason they're the same thing is, again, your calculator is trying to find the angle of this guy right here. Again, I'm going to call it alpha just because it's not theta, but it's this guy right there, alpha. So this is equal to alpha. This is equal to alpha. But again, but this time it's 180, and then we go past it by alpha, right? So this time it's a little bit different. This time I need to do 180, add this missing portion. And that gives me 247.4 degrees. This number makes sense because it's going past 180, but not to 270 degrees, right? So this number makes sense. right? So again, I would not use cosine. Same with this guy, right? There was not that, I mean, you would not even know 100% that you get this number. You're like, is that right? It might be right. I don't know if that's right or not. This makes sense to say, oh, 71.6. That's this guy. That's the angle. That's the triangle angle. Same here. That's the triangle angle for inverse sine. Okay, so those are two examples that I have to show you what that looks like. Now, the other ones are because they have other like questions, so I want to make sure we get to those as well. But again, if you have questions, please come in for support. I'm more than happy to show you, explain further. Okay. The first part, however, these are all the same, but now I don't have the equation. I know that I have my 0.34. So again, this is my x, y. I'm going to go ahead and just substitute in x squared plus y squared is equal to r squared to solve for y. So that's going to be 9 plus 16 is equal to r squared. All I did was square these, square root both sides. I get 25 equals to r square root of 25, which means 5 is equal to r. Now, if I wanted to, if they ask for what is the radius, or what is the equation of the circle, I know it's x squared plus y squared is equal to 25. If you want to write 5 squared, that's fine, but obviously we can simplify that. Sine, cosine, theta at this point should be pretty straightforward. I got 4 over 5, cosine is 3 over 5, and finally tangent is 4 over 3. Because it's in the first quadrant, any of them would work. I would honestly just stick with inverse sine. So inverse sine of 4/5, that's going to give me 53.1. Now, the second portion, it asks some different types of questions, and I really want to talk about this. I rewrote my sine, cosine, tangent on top to kind of help us out. But the sine of another angle, so this is asking for the sine of another angle has the same value as in part B. Through what point on the circle does the terminal side of that angle pass through? So kind of like what we talked about before, like with the Ferris wheel, right? There's some seat where it has the same height. In this case, we're looking at the same sine value. The same sine value. Now, at first, it's kind of like, what is it talking about? What does it want? It wants some other angle where this is true. So this is how I would start this. Well, I know sine theta is equal to 4/5 in this problem. And I know sine theta is y over r. So whatever this other point is on this graph must have, since the radius never changes, it must have a y value of 4. It must have a y value of 4, specifically positive 4. So as I look through my choices here, hey, this is a contender. My y value here is negative, so that can't be it. This is negative, this can't be it. This is 3, so that can't be it either. This is the only other possibility. Okay, and this is the same thing as saying, well, at this point here, at negative 3, positive 4, I'm going to get the same sine 4/5, right? Which makes sense, because then my opposite, again, is 4. My radius is r. Okay, now that's not as important. The important thing is you can be able to find which point it is. And similarly for the other ones here, cosine is the same value. Again, what point does it go through? Well, again, so actually, you know what? I'm gonna keep that point up for a second here. Just kind of track what we've been doing here. Okay, but cosine, again, in this problem, it's 3 over 5, but I also know that's x over r. Again, radius is never going to change, meaning these guys must match. Must be a positive 3. Again, not possible for my x value. Not possible. Maybe that's a 4. Must be 3, 4. 3 negative 4, I'm sorry. Which is going to be this point right here. So notice that my x values match. Right? They're all on this line. X is equal to 3. These guys are both on the horizontal line. Y is equal to 3. And last but not least, this is the trickiest one, I would say. But yeah, I mean, we'll go through it. Tangent has the same value. This one, I would say, well, I would still kind of think of it the same way in terms of what is the r point here. Our point here is 4/3. is y over x. Now, but because it's y over x, all my points are made up of x's and y's. So just put them, just divide them, right? This y over x is 4 over negative 3. This is a negative 4/3. This is a positive 4/3. Okay, so that can't be it. Negative 4 over negative 3. Well, this reduces to 4/3. So that might be it. Let me just keep going and see what's up with the other ones. Negative 4 over 3. That's negative 4/3. That also can't be it. Y over x is 3/4. That's not even the same number. So there is my answer. Okay, now let's take a look at another example. I think this one's going to be very different, but I think in a good way. This is the same thing as earlier, negative 12, negative 5. We had negative 5, negative 12 earlier, so it's going to be 13. If you want to go through and kind of calculate the number, that's fine, but radius is going to be 13 here. Okay, just kind of save time because we've done this a lot already. So this is my values. Now, be careful, negative 5 over negative 12. I can reduce this to positive 5/12. Okay? Now, again, I will just use inverse sine for all these because any other one, you're going to really get maybe potentially confused. Again, inverse sine of this value, inverse negative 5 over 13. I'm going to take, it's 22.6 or negative 22.6. First of all, I'm going to take the positive version of that. And I know that's this angle, alpha here. So I'm going to add 180 to that. Whoa, 180 to this. That I will get 202.6 degrees. Okay, and if this does not make sense, please let me know. Because I really want to talk about this right here. Again, the sine has the same value. Again, my radius is always positive. So sine theta is y over r. In this problem, it's negative 5 over 13. Again, radius is not going to change. I'm not going to worry about that. I need y equaling negative 5. This does not have that. This is positive. This is the one that makes sense. Okay, and so this all hinges on my new way of presenting sine, cosine, and tangent, where I have cosine theta is equal to x over r. My sine theta is y over r. My tangent is going to be y over x. Whoops. Y over x. Okay. Now, so again, r is not going to change because it's a circle. The radius is always the same. X must equal to negative 12. That's what I got to look for. This is positive. This is positive. Negative 12 is here. This is 5. So all I'm doing is looking for the x value for cosine. For tangent, I have to make that calculation of y over x. Okay, that's the thing about tangent. It's a little bit trickier because you do need to make that calculation, y over x. And in this case, I have, now, this one's a little bit tricky, 5 over 12. Oh, actually, no, I lied. Okay, this is, okay, never mind. Because I think your homework's a little bit different, but that's okay. So again, I'm just going to do y over x for each one. This is 12 over 5. That's not the same value. This is 5 over negative 12. That's not positive. Negative 5 over positive 12. That's also negative. This is the only one that makes sense. Now, just a side note for your homework, because I do see that people get confused. Let's say I have negative 1/2. You should know negative 1/2 is the same thing as negative 1 over 2, which is also the same thing as 1 over negative 2. It doesn't matter where I put the negative. These all mean the same thing. Okay, so just a small side note for your homework. Okay, so I hope that made sense. I know this is a slightly longer video. I do apologize for that, but I really want to make sure I break everything down. So I hope that helped. Let me know if you have any questions.